This is work shared together with my colleague and student Nicolò Busetto, who is now in San Francisco. In this work, we produced an experiment to verify whether word absolute frequency as reported in a frequency word list and represented in a dictionary for the creation of deep learning models is more liable of the inability or ability of BERT, the bidirectional transformer that everybody is using today, to predict the masked word than word relative frequency as represented by similarity cosine measures for vectors of word embeddings extracted from corpora to create the model, the starting model. So basically, the idea was to analyze the effect of context and sever it from the dictionary. To this aim, we needed to evaluate separately absolute from relative frequency of each word form, where absolute frequency is the one contained in the dictionary, and relative frequency is represented by the word embeddings cosine measure. So what we did, we ran the Italian version of the bidirectional transformer available under Hugging Face, which is called Umberto for the Italian version, and is based on Roberta, and analyzed in detail the output of the first layer, the so-called row embeddings. Eventually, we measured BERT's ability to predict the masked word, given the sentence and the text in which it was contained. Similarity was measured at first solely on the basis of cosine values. This was then substituted by a linguistically based measure, which extended the notion of similarity. In this way, predictability was given an overall parameter which better reflected the variables brought onto the experiment. To this aim, we created a small corpus for the experiment of 18 Italian sentences, including both poetry sentences and newswire text, in which the syntactic structures were non-canonical or discontinuous. So this was the main quality of these sentences that we chose. They had to contain non-canonical structure, that is, structure where the order of the constituents was not the one reflected in the canonical order, that is, subject, verb, object. It was discontinuous. For the experiment, then the same sentences were duplicated manually, modifying the structure into a canonical configuration. So this was done to verify the experiment. So basically, the corpus of sentences that we chose contained two important factors useful for proving our hypothesis: the use of uncommon words and the presence of infrequent syntactic configurations. Then the two different genres contributed the two factors present at the same time, but in poetry, this was done in great measure, whereas in newswire text, this happened with less infrequent structure and less uncommon words. Then we extracted the first 50,000 entries in the frequency list of the corpus used to build the model for the Umberto, for the deep learning model, and the frequency associated with the last item that we chose, or the 50,000 entries. The frequency was 1,377, so it was still very high. After checking all masked words, only a small number of words, word forms were excluded from the dictionary, only 10 over the 236 word forms that was contained in the corpus, but an additional 20 at lower frequency, very low frequency. From the 10 very low frequency, 3 were out of vocabulary words. So they couldn't be found in the, not in the 50,000 entries, but not even in the 1 million and over word forms that were contained in the corpus. These had to be segmented, as it usually happens, to create the model by the tokenizer of the model creator, which reduces unknown words or out of vocabulary words into a list of subword units with an overall loss of semantics and the embedding containing the corresponding word form. So what happens when you cut the word forms into subword units, which are chosen simply by sequences of characters, so creating a character string which can be found in the lexicon or not, depending. What you do is that you lose the semantics of the entire word, and so also the word embedding do not correspond to the original word. So what happened in the experiment? Here I'm showing first the masked words. As maybe you already know, the BERT deep learning model works in this way. It projects a certain number of masked words in the sentence according to a percentage that is being decided by the researcher. And so this masked word is chosen randomly. On the contrary, what we did, we chose every word form that had semantic content and made it into a masked word in order to check which were the words harder to predict for the experiment. From the tables included in the paper, the number of masked words varies as follows. There are 54 over a total of 83 word forms in the poetry subset of sentences, which represents 0.65 of the whole total. And then there are 86 over a total of 153 word forms in the newswire subset, which is very much a little bit more than half of the whole word forms. This difference, the difference in number of masked words per genre reflects the distribution of number of function and content words, which varies in the two genres. Poetry has more content words and less function words. So the function words do not constitute valid masked words, and we didn't use them. The opposite is true for the newswire domain. So, and here, the predicted masked words. So we ran the deep learning model using the text of sentences that we made. And so what happened was that the deep learning system tried to predict the masked word that we indicated. And now the words, the masked word correctly predicted by BERT, as you see here, there's only 19 over 54 in the poetry subset. That is only 28% of the all word forms were predicted correctly, and 69 over 86 in the newswire subset, which represents the 80% of the whole number of word forms. So if we take into account the the canonicity as a dividing parameter, since as I said at the beginning, what we did, we used the non-canonical and then turned the non-canonical into canonical. So in order to check whether the difference in structure produced different results. So if we split the number of predicted words according to the non-canonicity, what we get is there's in the poetry domain, there's only 7 out of 19. Only 7 are predicted in the non-canonical text. On the contrary, in the Newswire domain, the number of words predicted in the non-canonical subset is very high, is 31, almost half, so amounting to 82. 82 is the proportion of words predicted. So the first conclusion that we can draw, preliminarily, we can say that it is much harder to predict the mask word in the poetry domain. And the contribution of the manually created canonical sentence structure is much higher in the poetry domain than in the Newswire subset, since, as we saw, the number of mask word predicted in the non-canonical sentence in the Newswire subset is very high. So the difference between the two versions is not really important. So the question we must now answer is how these two facts, the effect of context, that is relative frequency, or absolute frequency, the dictionary, or both. So the answer would be contained by looking up the dictionary. That is to say, the list of word forms that is being used by the deep model to produce, that it will be used to produce the machine learning part in the hidden layers, which, as I said, we decided to cut it at 50,000 entries. In the tables reported in the paper, we show the number of high, low, and very low frequency for the two domains. So the results are as follows. The ratio of high to low and very low for the poetry subset is 0.82. That is, it is almost equal. And the ratio of high to low for the news subset is 0.14. In other words, the number of low frequency in the poetry domain is almost equal to the number of high frequencies. In the news domain, it is just the opposite. The low frequency are by far the majority. So we can draw a second important conclusion. It is much harder to predict the masked word in the poetry domain, and the contribution of the manually created canonical sentence structure is higher in the poetry domain than in the Newswire. And so, and from the results obtained, from the evaluation of absolute frequencies in the dictionary, we confirmed the result obtained previously from the cosine measures derived from the first overall layer. The Newswire domain sentences have a predictability score mainly determined by relative frequencies, that is the context. On the other hand, the poetry domain has a predictability score mainly determined by absolute frequencies, the dictionary. Now, since the number of word forms which haven't been recognized is fairly high, we decided to introduce a new type of evaluation using cosine measure similarity, but in addition to that, we introduced a number of linguistic factors or parameters. So we introduced a method for the evaluation of embedding vectors where the masked word was not found in the first 10 candidates. So rather than just considering cosine measures, which in those cases it will be very low, we weighted the output word on the basis of its linguistic overall features. In this way, similarity was decomposed into a subset of features: morphological, lexical, syntactic, and semantic. This was done in order to reduce the gap between the two frequency domains, the context and the dictionary, and come up with a single score. We used the following linguistic parameters to grade the best candidates. So we only graded the best candidate whenever the word was not contained in the first 10, was not recognized in the first 10. So, so obviously identity, this was given 1. Then the same word, but a different morphology and or different grammatical category. So that would be the case of a homograph with different grammatical category, a verb and a noun, different meaning, same word, but a different way, different meaning. A homograph, but not homophone. This is also, it could be fairly typical. In this case, the amount of score that would be assigned is below 1, so it would be 0.98, 0.96, 0.94. Then we go to a different word, which is, however, which could be a synonym, hyponym, meronym, antonym, and in this case, the score will be 0.8. Again, different word, same grammatical category, and or same morphology, again, lower, 0.7. Then absolutely totally different word. This will be 0.4 or 0.3. And then the mark that BERT, the bidirectional transformer, would assign to a word which is completely unknown, it will be a UKWN, and this will be equal to a punctuation. Rather than choosing a word, the BERT will be choosing a punctuation sign or a name entity. In this case, the score will be 0.1. The results are reported in the two tables in the last column and are represented as before, normalized by number of masked words. So the news domain, the number of masked words is 86, and the mark assigned by the scores is 0.66, the normalized marker. In the poetry domain, we obtain 0.46. That is, in this case, what we get is a 20% difference. So the hypothesis would be that, sorry, but this is something I don't want to see. The hypothesis was that the poetry text will be highly unpredictable and remains so also in its canonical version, with some improvements. So this has been confirmed by the experiment. So the first hypothesis was confirmed. Newswire text being much more predictable and the contribution of canonical version would not increase significantly the score. Again, also this hypothesis was confirmed by the experiment. Using the evaluation, the linguistic evaluation, we had a confirmation. The answer would be that the news domain has a much higher predictability score because it has a higher number of contextually predictable words in non-canonical structures, and obviously also canonical. And it has much lower number of low frequency words. This is reflected in the overall higher linguistically based evaluation score. On the contrary, the poetry domain has a much lower predictability score because it has a lower number of contextually predictable words in non-canonical structure, with a slight increase in canonical ones. And it also has a much higher number of low frequency words. And then, as a result, it has an overall lower linguistically based evaluation score. Eventually, the final predictability parameters we get show, as we noticed, a gap of 20 points between the two genres. This gap is also present in the distinction between canonical and non-canonical structures, thus validating the hypothesis that context rather than frequency is more responsible for the ability of the bidirectional transformer to predict the mask word. And eventually, an important parameter which needs to be taken into account is that poetry combines word not only to produce meaning, but to produce non-literal meaning, like metaphors, which are highly unpredictable. News, on the contrary, is more akin to produce word sequences and sentence structure that can be readily understood and obey literal meaning composition. So this would be the explanation from a pragmatic point of view, which depends, as you can see, on the semantics of the words and their sequences. Thanks.